Hello and welcome to this tutorial on alternating voltage. Today, we'll dive deep into the fundamental concepts of alternating voltage, also known as AC voltage. We'll break down its mathematical representation, key characteristics, and graphical interpretation. By the end of this video, you'll have a solid understanding of how alternating voltage works. Let's start with the basics. Alternating voltage is a type of voltage that varies sinusoidally with time. Unlike direct current, or DC voltage, which is constant, alternating voltage changes its direction and magnitude periodically. The mathematical equation that defines alternating voltage is V of t equals Vm sine of omega t. Let's break down this equation. V of t represents the instantaneous voltage at any given time t. It's the voltage value you get at any specific moment. Vm is the maximum voltage or the amplitude. It's the peak value that the voltage reaches, both in the positive and negative directions. Omega is the angular frequency, measured in radians per second. It describes how fast the voltage oscillates. T is the time in seconds. It's the independent variable that indicates the progression of time. The term instantaneous voltage refers to the voltage at any specific point in time. As time progresses, the instantaneous voltage varies according to the sine function. The maximum voltage, also known as the amplitude, is the peak value of the voltage. In our equation, it is denoted by Vm. This value represents the highest point the voltage reaches during each cycle. The angular frequency omega is crucial in determining how quickly the voltage changes over time. It is given by omega equals 2 pi f. Here, f is the frequency in hertz, and pi is the mathematical constant approximately equal to 3.14. Angular frequency is measured in radians per second. Frequency is the number of cycles the voltage completes in 1 second. It's measured in hertz. You can calculate the frequency from the angular frequency using f equals omega divided by 2 pi. The time period is the duration of one complete cycle of the waveform. It is the time taken for the voltage to go through one full oscillation, from 0 to Vm, back to 0, down to minus Vm, and back to 0 again. The time period is given by t equals 1 over f, which is also equal to 2 pi over omega. Now, let's look at the graphical representation of alternating voltage over time. Imagine a sine wave on a graph. The x-axis represents omega t, which is the angular displacement or the phase angle. The y-axis represents the instantaneous voltage V of t. Here's what we observe. At omega t equals 0, V of t equals 0. This is the starting point of the cycle. As omega t increases to pi over 2, V of t reaches its maximum value Vm. This is the peak of the wave. At omega t equals pi, V of t returns to 0. The waveform crosses the x-axis. At omega t equals 3 pi over 2, V of t reaches its minimum value, minus Vm. This is the trough of the wave. Finally, at omega t equals 2 pi, V of t returns to 0 again, completing one full cycle. The distance between two consecutive points where the waveform repeats itself is the time period t. This is the duration of one complete cycle of the waveform. From the graph, you can see t equals 2 pi over omega. To summarize, alternating voltage varies sinusoidally with time, following the equation V of t equals Vm sine of omega t. It is characterized by its amplitude Vm, angular frequency omega, frequency f, and time period t. The waveform repeats every t seconds, creating a continuous oscillation. Understanding these fundamental concepts is essential for analyzing and working with AC, or alternating current, circuits effectively. Alternating voltage is widely used in electrical systems, from household power supply to industrial machinery, due to its efficient transmission over long distances. Thank you for watching this detailed tutorial on alternating voltage. I hope this explanation has helped you understand the basics and key characteristics of alternating voltage. If you have any questions or need further clarification, please feel free to leave a comment below. Don't forget to like, share, and subscribe for more educational videos. Stay curious and keep learning.